Hi everyone, and we are back, and we are going to be doing even more logarithmic and exponential equations. So this is like the third video of doing some of these. I might even have one more after this, just to maybe put some word problems in there too. But I want to try to give you as many examples as I can so that you start to see more and more of what's going on. So let's see here. I'm going to start with something kind of difficult, and yeah, let's just jump right in there. E to the 2x minus e to the x minus 6 equaling 0. And this one is one that students stare at, because it's one that's, it's kind of hard to see. This is a hidden quadratic, okay? And to kind of see those hidden quadratics, kind of concentrate on those exponents. Notice this is just a constant on the end. You do need just that constant piece. You will need 3 terms, and your exponents go down in half. So like here we went from 2x to x. Hidden quadratics could be from 4 to 2, from 6 to 3. So what I'm going to do is I'm going to let u equal that e to the x. Okay? And now this e to the 2x, remembering how exponents work, I could write this as e to the x squared, because we can multiply those exponents. So that's, again, just something that I see really quickly because I've been doing this for a long time. You need the practice. So the more you're exposed to it, the better you'll get at these problems, the more comfortable you'll feel with them. So we're going to rewrite this now as u squared minus u minus 6 equaling 0. And now we should be in comfortable territory. It's a quadratic, which I will either try to factor it, or if it doesn't factor, go to the quadratic formula. This one does factor, u minus 3, u plus 2, which means u is either 3 or negative 2. However, we're not solving for u, we're solving for x. So I'm going to go back, and I have to solve these two little equations, because here's my u is e to the x. And to solve these, we are going to take the natural logs of both sides. The natural log of e undoes each other. We're left with just that x. Taking the natural log here, I have to remember we cannot take the natural logs of negatives, so we do not get any answers from that. Also, if you remember what the graph of an exponential function looks like, it does not go below that x-axis, so it is never negative. So we do not get answers from that piece. So we have one answer, and that is the natural log of x. Natural log of 3, sorry. Natural log of 3. All right, let's do another one. Let's do another exponential. Just throwing everything at us here. All right, ideas. This is what I'd ask you guys if you were in class. So I'm going to take a step back, and there's a lot going on in there. But it is set equal to 0, which is nice. Okay, so I have something equal to 0, which means I'm going to see if it'll factor. And there's a lot of stuff that it has in common. There's like an e to the x in here that I can pull out. There's an x that's in there that I can pull out. I think that's it. And what's left is 3 plus x equaling 0. So now I have basically 3 things being multiplied together to give me 0. For that to happen, one of them or more is equal to 0. So I have one answer already. X is 0, because if I put 0 in there, I get 0 plus 0 is 0. Here I get, move that over, x is negative 3. And if I did that, I'd have a negative 9 e to the x and 9 e to the x. That does give me 0, so there's another solution. E to the x equaling 0. You could take natural logs of both sides. Try to. However, we cannot take the natural log of 0. We can only take the natural log of positive things, so we do not get any solutions there. Another way to realize that is thinking of the graph. We have a horizontal asymptote at 0. It never dips below it, so it doesn't come and touch it and then come back up. It gets close, but it never equals 0, so we don't get any values there. We have two solutions, 0 and negative 3. All right, let's do this one. Let's do a log. Log base 5 of x plus 1 minus log base 5 of x minus 1 is equal to 2. All right, so we have two logs and we have a constant here. So our method is to kind of bring those logs together, combine and see if we can get a single log or isolate that logarithm and then change it to exponential form. Since I do have the same base, we're okay to do that. With different bases, you're going to have to go through a change of base to change them all into the same base. So let's see. And with the subtraction, that means we're going to be dividing. So I'll have the log base 5 of my x plus 1 over my x minus 1 equal to 2. And now I want to go into exponential form. So my base squared, so that exponent is the x plus 1 over x minus 1. 5 squared is 25. I'll go over here. I'm going to multiply both sides by that x minus 1. So this gives me 25x minus 25 is equal to x plus 1. I'm going to subtract x, so it gives me 24x, and add 25, so it gives me 26. And now dividing by 24, which is 13 over 12. And double checking to make sure that I don't make anything negative. Got real close here, but this is bigger than 1, so subtracting off 1, we're still positive, so we are okay. All right, let's do another problem. Let's see. We'll do this one. 2 to the 3x plus 1 is equal to 16. All right, 16. Well, that's a power of 2. So I'm going to rewrite that 16 as 2 to the 4th. Which means my 3x plus 1 must equal 4. Subtracting 1. Dividing by 3. If you did not recognize that 16 was 2 to the 4th, you could have done and just taken natural logs or logs of both sides and worked it out. And if you did go to simplify it, you would get that value 1. So you just have to be a little bit careful on that one. I am going to stop here. I wanted to stop on a nice one. And I have 3 more problems I want to do. 2 of them are word problems, so those will be in the next video.